Everyone, and welcome to our webinar on mobile web security with Jon Hagar. Before I give the word to him, I'll give you a short introduction on the company, the house rules, and the speakers of today. This webinar is presented by XPSoft. XPSoft is founded in 2006. We do QA consulting and software testing. We help companies improve the quality of their software. And we do that from offices in the US, Europe, and China. I'm located in Amsterdam, so a bit sad due to the loss of yesterday. Well, that happens. On housekeeping, everyone except the speaker is muted. We do encourage you to ask questions. Please use the GoToWebinar control panel on the right side of your screen and type any questions you have. Otherwise, we'll keep them for a separate Q&A session at the end of the webinar. This webinar will be recorded, and after the webinar, you'll get an email where you can find the location of the recording. These are the speakers. From XPO side, we have Sabrina. Hi, Sabrina.
Hi. Hello, everybody.
Great to have you here, Sabrina. Sabrina is located in the UK. I'm on the left side, the bottom left side. Jan. Sabrina does marketing, and I'm a managing director. And Jon, welcome here, Jon.
Good morning. For those of us in the eastern United States.
Yeah, we're pretty spread out today. Thank you very much, Jon, for joining us. This is the second time, right? We're doing a webinar together.
Yeah, I think so.
And you just published a book a couple of months ago.
Late last year, but yeah, it's been out for 4 or 5 months now on embedded and mobile testing, kind of in the style of James Whitaker's work. We'll see some reference to that in today's presentation.
That's great. What prompted you to write this book?
I'm a big fan of attack-based testing with patterns that James Whitaker has written several books on, which basically target common errors, and so I did a lot of work analyzing errors embedded in mobile devices, including the security domain, and in talks with James Whitaker realized that there was probably enough information with the years of experience that I had to write a book, and it's topical given things like the Internet of Things, embedded, and mobile, so that's kind of why I went with the book.
Yeah, it's very popular. A lot of people speaking about it, also in Europe.
Yep, in Asia, we're putting software in everything these days.
Yeah, all over the world. Well, I'm sure Sabrina will include a link to where people can get it when she sends the information on the recording after the webinar. And without holding up, I'd like to give the word to you, Jon. Please continue. I give the slides to you as well.
Okay. So am I in control now?
You should be.
Yep, show my screen. There we go. Anyone here? Okay. So, do a few things. So this is going to be a session on mobile web security, dealing with mobile devices. I want to talk some concepts, but really focus on testing. I'll give you some general concepts, but I find an awful lot of the presentations on mobile security tend to focus on things like what happens if you lose your device. And we'll mention that a little bit, but I'm a big fan that when we develop apps and mobile things, we want them to be secure before we put them out in the field. So having been a college professor as well as a practicing tester, I always like to include some basic definitions and concepts, get us all on the same page. I want to tell you some of the problems we've seen in the industry. I'm a little bit strange in that I spend a lot of my time reading articles and reading information that comes out on the web for various issues and errors. not just mobile but embedded, and also focusing on the security areas. I also want to talk some specific samples of this concept of test attacks and how they can play into a robust program addressing the security of mobile devices in the web. Give you some information on some of the historic attacks out of some of the other books, particularly from James Whitaker. And note that what we'll see here in this presentation, what's in my book, what's in James Whitaker's books, these are only beginnings, and encourage everybody to be working in this area. And a little bit of what I see the impact to the test engineering domain and where people might take this for careers. There's a lot of demand right now for skilled people in security testing, particularly in the mobile space. Mobile, smart, handheld devices, I think we pretty much all know what these are, but I have a fairly broad definition of mobile. Certainly the smartphone that you see down there in the kind of the center bottom is what everybody thinks of, smartphones, tablets. But a lot of us that work in the industry now realize that a lot of medical devices are in fact essentially mobile. They're connected to the internet. They may fit a little bit more into the Internet of Things, the IoT stuff that I've been researching. But these devices share a little bit of the IT world, but they also share some of the embedded world. And I came out of the embedded world, then got into PCs and ITs in my testing, and then finally, when mobile smart stuff started happening, it kind of is a natural transition for me to go into there. These devices in the embedded space have limited user interface, but we know that the smartphones have much more user interfaces. And when you start looking at things like airplanes and cars, they're certainly mobile. They have these devices embedded in them. We're seeing screens in the cars that are essentially like a tablet. And now the cars are starting to get hacked. And I've read reports on that. So we're getting more and more power, more and more memory, more and more features, more and more software, literally tens of millions of lines of code in some of the smartphones. That worries me from a security standpoint. There's also in these systems risk from noise, time factors, and sensors, which a lot of the PC, IT world is less than familiar with. So testers coming out of that world and security testers coming out of that world have a whole new set of things to deal with in the mobile space. Hence why I'm talking about it a little bit is I think everybody has to understand that some of these mobile devices are a little bit new and different. Definition of security here. For me, it's keeping the physical and logical parts of the system safe from harm, compromise, and adverse consequences. In general, that can include the internal information of the device, things like we want it encrypted, we want passwords on that. I think we're all pretty much familiar with those kinds of things coming out of the PC and IT world, and now see the same kinds of registration features on our smartphone. But now we've got transmission of information. PCs and ITs, sometimes Wi-Fi, but oftentimes a hard line. We've got these devices now where they're using Wi-Fi pretty much as we walk around to our favorite coffee shop. They're hooked into various service providers by the cell phone network. So we see unsecured Wi-Fi. We see threats from those kinds of things. And then you have the external threats, usually logical. What I mean by that, there's a fun little name called social engineering by the people that do it. It's really kind of the crackers and the hackers that are trying to find vulnerabilities in systems. Once upon a time, we kind of only worried about it a whole lot in the IT and web world. Now, in the last few years, we've seen more and more hacking, more and more viruses, more and more rogue apps and malware targeted at particularly two systems, certainly the Apple products and the iOS, and then the Android products. So we're seeing this more and more, largely because the number of devices are increasing faster than the PC and IT world. So it's kind of a natural progression for the hackers to go into that. Hence, the security concerns start really worrying me. I mentioned James Whitaker now several times. He defines kind of four basic capabilities that all software has. And it accepts inputs, it produces outputs and transmits them to the environment, it stores data internally, and it performs some kind of computation. And we see in the security world people attacking all these areas in one way or another. So when we're thinking about testing these, we have to start thinking about testing it from the security standpoint on these four. I kind of refine that a little bit in the mobile space, where I already mentioned we're connected to various kinds of wireless networks, and we've seen people putting out unsecured Wi-Fi. We've even seen Wi-Fi where somebody's putting it out there to essentially hack you when you're using their Wi-Fi. The other kind of thing that we're seeing a lot in the mobile space, particularly the Android space, is the number of platforms is huge. What's known as the fragmentation of the market, particularly in Android, causes testing to be difficult, and therefore the security testing maybe doesn't get done against all the platforms, and there we have potential vulnerability. Certainly we have many, many apps. We have rogue apps and apps that maybe aren't on the app stores, although there have been a few cases of malware on app stores. Usually those get taken down quickly once they're detected, but we can get malware in through the apps, and there's just so many apps, millions of them, and a lot of them I don't believe are security tested. So we have this large amounts of features, and there's in the mobile space, just like the embedded world, we have sensors, we have control systems and critical features that are all provided sometimes as part of the OS. How well are they security tested becomes a concern for those of us doing security testing. I'm not going to read all these on the page 10 here. These are definitions, again, from a lot of my teaching background. I like to put in definitions of the terms I use. Most of these will be familiar to you. But for reference, later on when you're looking at these charts of this presentation, here's the way I use terms. An awful lot of these do not have 100% agreement in the industry as to what they mean. So I always like to say, here's what I mean for this presentation in this particular case, so you're aware of things. So the problem and the context, what are we seeing? What's some of the industry data out there? You can look at these as kind of scary stories, if you will, ghost stories type of things. These mobile and embedded systems, they're highly integrated with the hardware, the software, and the solutions. We're starting to put a lot of trust on them handling data, and people are storing more and more sensitive kinds of information, financial information, personal pictures, all kinds of things on their phones, and a lot of times we're using them to perform critical tasks. I have people showing up in my house in the mountains of Colorado that are using their phone to do navigation, but there's bugs in some of the navigation software, and they end up at my house instead of 2 miles away at a hot spring. Kind of critical for them that they don't want to be lost, but they are. We've also seen researchers finding security holes. The Coventry scan of 2010 of Android found, and they were doing static analysis, by the way, about 0.47 defects per 1,000 lines of code. which you go, well, gee, that doesn't sound a lot, but then there's 10, 20 million lines of code out there in some of the Android products. That means there's a lot of holes. They found about 359 defects, 88 of which were considered high. Now, the good news for all of you using Android is they've come back and fixed most of those things, but it shows you the tip of the iceberg, I believe. And another set of researchers, Jon D and Zach Lanier, I'm probably mispronouncing names, found holes in the Android with Angry Birds, a little bit of that malware, rogue app stuff. In the robotic and drone world, which a little more towards the embedded side, but they're certainly mobile, they've been rumored to be attacked, and cars and medical devices have been hacked. These mobile devices inside of cars have actually been hacked. Those things scare me. Even more scary coming out of the embedded world, just for a little bit of late night scary. There was an attack on the Best Davis nuclear power plant. The oil and gas industry have had a couple of viruses, Night Dragon and Shamu. And there's been reports of infrastructure where a water plant was attacked in Harrisburg and a Texas water treatment plant was attacked. And even some reports of blackmail. Since I built some of these charts, there's now some viruses that will hijack your phone, lock up your data, and you'll have to pay some ransom to get your phone back. The logical side of the phone, not the physical side of the phone. So this is changing. Now, the traditional world and PCs and IT systems and the web, they've been fairly active in many organizations and many companies and many providers for years with security. Some better, some less in terms of diligence, but it's been well practiced in many cases. For a long time in the mobile world, before the days of smartphones, we just didn't worry about it a lot. Now with the usage overtaking, as I mentioned earlier, it's become a big concern on viruses and things like that. Lost or stolen devices have become a growing concern, and how do you protect that data? There's now wipe programs and those kinds of things that you can basically get your phone cleaned. I'm not going to be talking about a lot of those kinds of things. Physical security, that's another set of presentations and topics there, but I mention it here at least. And then there's the networks side of things and spoofing. I do have a little bit on some spoofing attacks, and I will mention that we've seen reports of what's known as GPS spoofing. That's one of the attacks that I won't do much more than just mention. But we've seen cases where we think the GPS systems, the satellite systems, have been spoofed. Kind of scary stuff for those of us using our smartphones to guide us around the country and the world, that maybe GPS is hackable. What I want to focus on for the rest of the presentation are the issues with errors, bugs that development introduces into the software, and the features that may have errors. And these kind of features and undocumented features are what we know a lot of the viruses, a lot of the attacks by hackers. This is what they go after. And it seems like almost daily, certainly weekly, I read various exploits that this outside community finds. They get plugged by some of the major developers and providers, but there's a period of time of vulnerability. And I like to advocate that as responsible providers of apps and providers of software and testers, that we do a little bit more to find these kinds of things before they get out into the field. In a perfect world, we could build perfect software, but that's not possible. It's never going to be possible. So I'm advocating strongly that testers, depending upon the risk of your app and the risk of your software, be more proactive with security testing of mobile apps and things like that. I think we can do a much better job there as testers. Here's my list of mobile security concerns and a little bit longer list than what you saw earlier. The fraud and identity theft, the worms, fault injection and error exploitation, that's where the bugs get used. Processing on the run, where we're moving around with the mobile device and other systems are watching us as we come and go. These are both good for marketing, but they're also questions about privacy that come up. Hacks and having your system compromised can impact your power usage. I'm always running out of batteries, memory, and CPU usage. It seems like my phone runs slow sometimes. I run virus protection on it, but it's a constant game with the bad guys. There's eavesdropping. We know this going on. There's hijacking, clickjacking, and voice and screen capture. Security concerns that are out there. And then there's the physical side of file snooping while you're moving around in the lost phone. Now again, I'm not necessarily going to cover all of these. I want to focus on the side of the attacks for errors. And we have a poll here. And Sabrina, are you going to run that now?
Running.
She put it up, John.
Yep. We got that?
Good to go.
Oops. Okay, am I back in control now, Jon?
Yes, you are.
Okay. So, and maybe when we get to the end, we can get some of the results of these polls. I don't want to take people's time too much. So, what I want to focus this presentation on are the items highlighted in red here. The software bugs that we need to test for, some attacks on the inputs and outputs, noting that there's a lot more attacks than I can cover in a short webinar. And then some, I'll call it impersonation. What I believe testers should be doing is kind of impersonating, playing the role of the bad guy user. I realize that's maybe hard for some of us to do, but I think we can learn how to do that. So that's kind of what I want to focus on. What we know about bugs is they come in from requirements, the logic, the control, the data. There are security bugs, there's interface bugs, there can be bugs in games. These all come out of the IT world. As we move more and more into the mobile space, we pick up all those bugs, plus we pick up some that are, I'll call it specialized, if you will, or unique to what we see a lot in the mobile world. In the mobile world, most of us gone to very short development cycles, oftentimes agile. Things are very quick, very incomplete. I've heard a few app developers go, well, I just don't have time to do the testing. I want to get my product out there. That worries me a little bit because that probably means there's more bugs there, there's more security vulnerabilities. I already mentioned there's many kinds of apps and hardware. Those things concern me far more proliferation than what we see in the PC IT world. And also many times there's a lot of dense, complex code, literally millions of lines of code, each of which can have a potential for vulnerability. And finally, there can be a lot of performance issues with these devices. So a little question, not so much a poll question here, but something I always like to ask everybody is, do you know your bugs? In the projects and places you work, do you know the kind of bugs your organizations produce? For years, I've worked with what are known as error taxonomies. It's what the book and all this attack-based testing is based upon, are errors found from analyzing many, many errors into a taxonomy. I find testers don't learn enough from their past errors by using something like a taxonomy. I'll mention Lee Copeland's book on software test design has a chapter on error taxonomy. It's pretty good stuff. Security testing attacks. So here's kind of the meat of some things. I should define what an attack is. For me, attack in part is the process of attempting to demonstrate that a system, which can be hardware, software, and the operations, so the whole thing, including the software, does not meet, that's the key, the stuff there in red, does not meet the requirements in the functional and non-functional objectives of the system. Now, this is fundamentally different from requirements verification checking, where we're trying to show the requirements are met. We usually have to do that. I like to call it the necessary but not sufficient part of testing. And in these mobile and handheld and embedded devices, the system, for me, includes the hardware, the software, the servers, the operations, the users, the web connections, the sensors. It can go on and on. And so I try and exploit my attacks against all those things. But when I did my research, I found that many of the bugs tended to cluster in the does not meet part. Significant numbers tended to occur over and over and over in some areas that were pretty easy to I'll say, detect and prevent. That led James Whitaker and some of his associates and then myself to define particular patterns of testing to go find these bugs. So an attack is based upon a common mode of failure, and some may see it as a negative because we're trying to break things. Being a tester, I see it as a positive because I like to break things. Probably a personality flaw there, but I like to find the bugs. It goes after the bugs. An attack can use a variety of test techniques, sometimes together, and test concepts, sometimes together. So it's not at the lower level of a technique. It's somewhere in the middle where we combine things. We've seen more and more of these attacks get published. As I mentioned, I think James Whitaker's got 3 books out. I've got a book. But I always like to encourage all testers to be a little bit suspicious of anything anybody says in our world and recognize that these patterns are not test cases. These are not test procedures. They are patterns that you have to pick up, understand, and then modify for your own local context. So if you're looking for a cookbook, the only way I've ever been able to cook or create cookbooks is for a particular project when I'm writing my test procedures or doing exploratory testing on the fly. But I came to realize that the techniques and patterns could help me do these things. So the first attack pattern I'd like to give you is the identify security fraud. Now, this one will be pretty familiar to most of us, particularly anybody coming out of the PC and IT world. You want to apply this when your app, your mobile app, has things like account numbers, a user ID, and a password, or is using location tags to determine that the device is in a place, say like a store, and can get information about the store when you walk into that store. We're seeing apps that do that. And if there's some kind of restricted data that you don't want general access to the public, which, by the way, might include people's personal pictures. They may not want their personal pictures out there exposed to everybody. So we want to worry about this getting information off of the device. And the current approaches on how people solve these things, you have the server-based side. Pretty much everybody on phone calls is probably familiar with that, where you have the registry. That's the infamous user and password that we have to type in to identify who we are. And this is part of the attack, is to go after those registries. There's common passwords, there's common approaches, there's some tools now even to go after these things. In this presentation I don't get into them, but I'll just mention them. Things like PK crack, I think that's coming up here in a bit, and something called fuzz testing, which throws just hundreds of user IDs, thousands, millions maybe user IDs and passwords at it, and surprisingly we get into systems a lot doing that. Probably means they're not as secure as they would like to be. Location-based devices, these are apps that may be produced by a retailer that you load onto your system, and when you're walking around that particular store, it's supposed to come up and give you helpful information or prices or something like that. These have the potential of being hijacked both when you're at the store, but maybe elsewhere, because the app may be running all the time looking for that. There's also possibilities of persistent data that contains sensitive information that you want to look for and maybe flag as something that shouldn't be kept around on these location devices after they're no longer in the store. And then there's what's known as profile-based. And some of you may be familiar with this. It's been in use in some of the credit card industry for years. This is where you are monitoring the user in the app for, I'll call it, common usage. And in credit cards we see it if all of a sudden you go to another country or another part of the country. I've had this happen to me because I travel a lot. I will get a phone call from my credit card provider going, "Are you in Florida right now? You're normally only in Colorado. Why are you in Florida?" Because they know people might steal that information and be using it elsewhere. So we have these systems that monitor that and use that. So is that an issue? This all traces to privacy. We want to keep people's information private, their financial data private. This is a big deal and increasing. I define some sub-attacks on this. There's the identity fraud spoofing. This is where we try and fool the device into thinking we're somebody else or some other aspect. The spoofing sub-attack gets defined in more detail in the book, but I mention it here. There's also where we're wanting to fool things so we can hijack it. A couple of people that I've been working with, Sheena Hagerman, she may have her PhD by now, but she was working on a PhD. Her reports and information show how to use Wireshark to sniff and decode information being broadcast over both Wi-Fi and potentially, if you could get access to it, a cell phone network. It was pretty scary stuff, what she was doing, and in the nature of research. Next approach is location. Can you fool the device into thinking that it's somewhere else? Is there information, because sometimes these devices, when you're, say, in that store, it keeps information. It might even be keeping things like credit card information in a permanent file on the system. Now, the typical user can't see that, but the hackers can go in there and look at that. So a better design solution is to keep that kind of information in a temporary file and get it flushed out and cleaned out. That's the kind of thing as testers we would want to be going in and poking on when they're using this location-based profiling system. So you want to poke around in those kinds of things, and people go, well, our files are encrypted, so we're safe. But be aware, what level of encryption, and testers should ask this quick question, what level of encryption are we using? Many of the simpler levels of encryption have now been broken. There's tools like PK Crack. There's some people, hackers, that have used digital signal processors to break systems that were encrypted. So we're having to go to higher and higher levels of encryption. Looking at these kinds of things are the types of things that in our testing we want to be doing, and again, trying to break in, do the same things the bad guys do. Now, there are always at this point questions of do we have time to do this? Am I saying to do this with every single app out there? Probably not every single app, but if I were building a banking app, I might want to do a little bit more of this. If I were building a banking app that used location information to know when I walk into my local bank, I might want to do a little bit more because the risk has increased. Oops, okay, so spoofing the location and the user. Ask yourself, can I spoof the location or the device that it's broadcasting? Can I fool it? Now, this gets into some fairly sophisticated stuff. I'm not going to be able to get into the details of it, but suffice it to say there's tools, there's hardware that can be set up to do these things. Not every tester would go do this kind of stuff, but we mention it as the kind of attack that should be considered for certain types of mobile systems and mobile apps. It's the kind of thing that you need to be aware that they're out there. This is where there's attempts to take over the identity and understand the user, maybe the user profile. The bad guys are trying to get access to the data. The profiles use things like location, time, and types of transactions. Those kinds of information is what is being checked to see, is it typically what John Hagar does? If it is, the system's happy. If it's not, something may get flagged and all of a sudden my mobile app may not work. That upsets some people. So you want it to do it at the right time, not the wrong time. Again, if you explain to people that, hey, we're trying to protect your sensitive data, usually they'll understand, but it's the kind of thing, again, we should be testing for these things. So there was a little bit of overview and some of the detail on 2 or 3 of these attacks. I want to mention that there's many more other types of attacks related to security. I'm going to list a few of those now, both from my end and from James Whitaker's end. App and configuration update attacks, an embedded phishing attack, which is applicable to the mobile, virus and malware on the apps that try and hijack your phone. And there's an interesting one that maybe a lot of mobile people and a lot of mobile app developers do not think about, but the operating system and the other elements that come provided with the mobile device, can they be trusted? In many cases, we saw earlier with some of the Coventry reports, they can't be trusted. They're vulnerable. Now, this constantly gets updated, but there's new vulnerabilities found all the time. As testers, I think we have to pay attention to these other outside non-trusted software and at least raise it as a risk to the project so that people understand there's a potential vulnerability there from the security standpoint. I list some of the specific attacks out of my book here: penetration attack, identify social engineering and spoofing, location profile spoofing, GPS spoofing, and viruses. Those are some of the attacks that related to what I was just talking about, and then some of them are explained in more detail in the book. I also wanted to present here James Whitaker and Thompson's book on breaking software security. It had about 19 attacks in it that I felt, while they were out of the PC IT world, which is what the book was written at, as I looked at the attack and the pattern and the type of errors that they were going after, it seemed very applicable to the mobile and the embedded space. So that's why you see the yeses over there in the column. You've got the attacks that I've just kind of outlined. You've got 19 attacks there on Whitaker's book. So if you're getting the idea that there's potentially a lot of security test attacks that we might want to consider when we're doing this, you're getting the right message here. Many more attacks do exist. I wouldn't claim, and I know James Whitaker wouldn't claim, that we've identified all the security attacks one wants to do. It's a never-ending game with the bad guys. The bad guys are constantly finding holes. As we find patterns of errors in the holes that they're finding, I think we have to adapt and have more patterns of these test attacks that we do on security. The infamous saying that the best defense is a good offense applies here. We're trying to defend our apps and our devices. We do that by having a robust security test program for those apps and those devices where the risks identify it. So the bottom line for me, there's device security. I haven't talked a lot about those, but you have the registration, you have the wipe and disable programs, you have encryption, monitoring and cloud things. Security testing may come into all of those. I mentioned a few of them in this presentation, but there's others. On the development side, we probably want to be working on having better requirement specifications in the security world. Some apps and some development groups, I think, have that, some don't. The software design and construction itself can be much more robust, I believe, and the support processes, such things as configuration management and what version of the software we've tested and what version's getting out of the field. Those may impact the security area. And then finally, I'd be remiss in not mentioning that the operations and IT operations side can play a big role in security. Not so much for the security testing crowd, but things like governance, product controls, limiting access, both logically and physically, and then the overall cybersecurity. I've talked about a little smaller part of the big pie here of mobile security in the testing area, but I think it's often overlooked. I think many mobile people, many app developers don't think about this security testing maybe until it's too late, until they're exposing things and maybe on a nightly news. So we've got another poll here, Sabrina.
Yep.
Sabrina, let me know when you close the poll.
I will do. Okay, thank you everybody. Poll closed.
Okay. Move on. So wrapping up here a little bit. I've covered some of these in the presentation. I mentioned a few others in passing. Realize this is a little bit of an eye chart, but this one kind of gives my favorite attacks that I like to do when I'm doing security testing. I like to do a penetration attack, maybe combining that with a fuzz testing attack, and those are my kind of first top two. If the system I'm working with, the device I'm working with, is subject to maybe a spoofing concern, that would be next. Then look at the file checks. Are there persistent, temporary but not temporary files that are left around the system that I can access? And if they're encrypted, can I break that encryption? Then I move into the breaking software security world, the things that James Whitaker's book talks about. And then finally, how susceptible is my system and app to viruses? And somebody taking the thing over and creating a rogue app that's got my name on it, that all of a sudden somebody's blaming my project for an app that's been taken over by a virus.
John, can we share this with some of the
Yes.
attendees? Okay, it's hard to read for us. Thanks.
Okay, so I always like to part with some advices to how to people to increase their skills in this area. I'm a big believer that testing is a highly skilled profession. So here's kind of my list of how you might want to move in to security testing if you're not there, and if you are there, things that you can maybe work on to make things better. I think you want to be able to apply some of these attacks that I've listed and are covered in my book and James Whitaker books, but then I think more importantly you want to start synthesizing your own. These are just starting point patterns. I'm a big believer in critical thinking. In this case, what I mean is think like the bad guys. Read some things and understand how they think. Next on my list is the exploratory testing, which is the usually non-scripted testing on the fly and following the smells. A lot of security issues and holes. You see this in the hacker community. They talk about getting a feel for something, it's smelling not right, seeming not right, and then digging in and then finding the real vulnerability. That's a hard talent to develop, but I've seen people that have developed it far better than I, and it's something to work towards. I think working in this area, work in automation, modeling, and some mathematical approaches. All of these now exist. I mentioned fuzz testing already. That's a form of mathematics, by the way, that's showing quite interesting, promising. I mentioned several times the notion of risks and risk-based testing. Not every app needs the same level of security testing that other apps do. This leads us into having testers that have good risk assessment ability and good ability to define risk-based testing. And then finally, I think we all need to improve our general test skills in areas of processes, techniques, and getting the right level of documentation. I don't think you need to document everything, but sometimes you need to produce some documents. Test engineering, testers, we want to have that working like the bad guys. We want to have the hacking attacks. We want to find the vulnerabilities before it goes out in the field. I like to provide the information back to the development team as soon as I get there, as soon as I start looking at requirements, if I'm there before there's code or when there's only prototype code. That's when I like start going, hey, you know, I just found a potential vulnerability. Let's get it fixed before we go out. And then towards the end of the development cycle, that's where I say kind of get nasty. Think like the bad guys. Maybe you don't have a lot of time to do that, but just a little bit of time may provide information back to the other stakeholders that says, hey, maybe we should do a little bit more. And then finally, I'd say practice, practice, practice. I've been doing testing for over 30 years. I'm still learning. I'm still practicing. I do have my classic warning that I do on these things is The security types of attacks and the information that are in this presentation and some of these books get both the knowledge and the approval of the owners before you go do these things. There are potentially severe legal implications in some of these things. Please do not go after this presentation and try and hack into your favorite mobile app bank website. There's organizations out there monitoring for those kinds of things. It's illegal. But when we're hired to do it as testers inside of an organization, that's when I want to see these things happen. Maybe in a sandbox is the name for it, like a test lab in the security world, where we can't hurt things. The analogy I like to use is I can conceptually tell you how to drive your car 150 miles an hour. You can do that, but chances are you do that for too long, you're going to get a ticket and face some severe legal implications. So be aware, these things are necessary for testers to do, but only when I'll say the powers that be, the stakeholders, approve it. Please don't do it on your own. So hopefully I gave you some food for thought on these. These are just starting points. The amount of mobile devices, the features, and the connections are growing, meaning that the security threats are getting bigger. I mentioned a little bit about the Internet of Things becoming more and more, in some ways, mobile, certainly connected into the web system. This just introduces a whole new set of potential security threats in my mind. We know that there's impacts to the systems, to the software that introduces some of the vulnerability, potentially even to the hardware, and finally to the subordinate operations. All these areas can be affected by security threats from mobile devices. Again, I gave you a little small slice of the pie in the security testing of the software with attacks. It's a big problem space, lots to learn. And I think we got a final poll here. Sabrina? Let me know when it's closed, and we can. I always like to cite the references where I get good information from. And then we'll go to Q&A. And we're almost on time.
Okay, poll closed.
Okay, poll closed. Okay, so I always like to note that I stand on the shoulders, backs, and knees of a lot of very smart people. I mentioned a few of them going through here, but I always like to say that I learn a lot from these people. James Whitaker, Elizabeth Henderson, Lee Copeland,
John, we're not seeing your screen. Sorry.
Tim Kainer, and Philip Liu. So I always like to give credit. There's some book references here. My book, Software Test Attacks, to James Whitaker and Thompson's book, How to Break Software Security. And I do like, as a nice starting point, Lee Copeland's Practitioner's Guide to Software Test Design. And I'm not going to read all those other references, but I always like to mention the books.
John, sorry, we didn't see your screen. John, sorry, we didn't see your screen with the references. Could you put it up again?
These references?
Yeah, we don't see your screen.
I don't know why. Did Sabrina not return control?
Yep, the poll's closed.
There's like a...
How about now?
Nope, not yet.
Yeah. I'm not sure what happened there.
Otherwise, we got some questions on training material and references. Otherwise, we can send them after the webinar. Yeah,
the resources and references are in the end of the presentation. I'm not sure why it's not being shared.
For someone who wants to get specific training on security or mobile security testing, what would you advise him or her?
I would start with I would start probably with those books. Look up Herb Thompson. He's got a company that I know has training in general security. I do some training based upon my book on some of the attacks, so those would be my starting points. There's other companies that cover the space a little bit. I don't have them in this presentation. If somebody wants to drop me a line with that question, I can look it up and email that back to them.
Okay, that's great. We had a question from Frederick earlier in the webinar, and he's asking if the strength of Wi-Fi signals decrease the vulnerability. That applies actually both to Wi-Fi and cell phone strength, because we know the signals strength of cell phones go up and down. I'll say I'm not aware of vulnerabilities that have been exposed from that aspect. I'm not saying that they aren't there. I'm just not aware of that. Now I am aware of bugs in software that have occurred because of those kinds of things. And so it's not a big extension to say, well, if it's a bug in the software, it might turn into a security bug. So I know of bugs that are associated with signal strengths, and maybe more importantly, dropouts of signals during a transfer where you get a partial transfer or something like that. I'm not aware of a security bug that was directly traced to that, however. Okay, interesting. Since we're approaching the hours, we have a couple more questions we can address afterwards through mail. I'd like to close with something that was in the news in the Netherlands recently. A former commander of the Dutch Armed Forces, he mentioned he thought security should be a part of the yearly report of corporations. What do you think of that? I think that's got some potential. I'm not sure that there's regulations in place enforcing that right at the moment, but I know many companies, at least in the U.S., include information on security in some of their reports. I think it's maybe a kind of voluntary thing, but I think from the standpoint of nobody wants their personal data or their banking records or those kinds of things exposed. And I think it'd probably be a good idea for companies to report what they're doing more and more to show they're being proactive from, I'll say, positive advertising standpoint. What we do know about now, including software bugs and security bugs, that when they get exposed, company stock prices oftentimes take great hits from these things. Literally millions of dollars, if not tens of millions of dollars, can be lost over one of these kinds of things that may result in a recall or security vulnerability. So I think we'll probably see more and more of those kinds of things get reported, both in the news media, and then probably companies will realize that it's to their advantage to say what they're doing in annual reports or whatever. Exactly. Okay, that was very interesting. We just hit the hour, so we made it exactly on time. Jon, I want to thank you very much. It was very interesting. Thank you. And if there's other questions, email them to me, and I will email the individual people back, both now and in the future. Yes, we will. Thank you very much, Sabrina. Thank you very much, all attendees. Sabrina will update you with the slides and the location of the recording. Any other questions you guys have, we can address through that as well. Thank you very much, and have a good day. Bye-bye. Thank you.